So here we've got a rather tricky probability question. So here's how it goes. We've got two jars. So these are my artistic renderings of jars. Okay, we'll give them kind of more of a top. So this one is jar A, and this one is jar B. And so in jar A, let me see if I can get the colors right here. There are 5 yellow marbles, and there are 8 green marbles. 3, 4, 5, 6, 7, 8. And then in jar B, there are 2 yellow marbles. I know it's hard to see those. There's 2 yellow marbles and 6 green marbles. So we have two yellow, or sorry, how many? 5 yellow over here, 2 yellow over here, 8 green over here, 6 green over here. And here's how the game works. We take two marbles go from jar A to jar B, and then we choose one marble out there. And we don't know what marble that is. And so this is a pretty tricky question because there's kind of a lot of action. There's lots of different possibilities. And so using a tree diagram is a good approach here. Okay. And so what we're going to do is answer two questions. The first one is just what is the probability that the marble you draw out of jar B is yellow? So try to answer it yourself if you can before you watch. And then we'll ask a second question involving conditional probabilities. So I'm going to make a tree diagram to represent what's going on here. So the way I see it is that there are 4 different possibilities, really. The first marble that goes from jar A to jar B could either be yellow or green. Why did I write an A? That's funny. Yellow and green. Sometimes you just write the wrong thing. Yellow and green. And then after that, we have a second marble that could also be yellow or green. So that's where the 4 different probabilities come from. Okay, so the first marble, well, there's 5 yellow marbles out of 13. And then similarly, there's 8 green marbles out of 13. So that's not too bad for the first probability. Now, in the second probability, it's conditional. It depends on what happened in the first set of branches. So to draw a second yellow marble means, well, there's only 4 yellow marbles left over out of 12. To draw a green marble after the yellow, there were 8 green marbles after 12. Remember that at each branch of this process, your probabilities need to add up to 1. So like that adds up to 1, that adds up to 1. It's just a good way to double check your work. If we draw a green marble, then there's still, I guess I kind of wrote the yellow and the green in the wrong spot. Let me fix that here. There we go. So if you draw a green marble first, then there's still 5 out of 12 that are yellow. And if you draw a green marble first, then there's 7 green left over out of 12. And again, that adds up to 1, just like it should. So what we can do is multiply the probabilities along each of those branches to get here. 5 times 4, 12 times 13 makes 156. They're all going to be out of 156. So 8 times 5. Another 8 times 5. And then 7 times 8 is the other 56. Okay. So then what we can do is we could reduce those fractions down, or we can leave them as they are. Either way works just fine. The first question we're going to ask ourselves is, what is the chance that you draw a yellow marble out? So the probability of drawing a yellow marble is, what you do is you look at how many marbles are yellow in each of these branches. So this one has 4 yellow, the top one. The middle 2 each have 3 yellow marbles, and the bottom one has 2 yellow marbles because there were already 2 yellow marbles, and all I did was draw green marbles over there. So the probability of yellow is, well, there's 4 marbles out of 10 that are yellow in the top scenario. And the top scenario happens 20 out of 156 times. Then there are 2 identical situations. The 2 middle branches both have a 3 out of 10 chance of drawing a yellow because there's 3 yellows out of 10, and each of those has a 40 over 156 chance of occurring. And then the last one, there is a 2 yellow out of 10 chance of drawing it with a 56 out of 156 chance of occurring. So if we go through and try to simplify some things with our fractions, what that makes 2, 4 goes into 156 39 times. Let's see, 10 in here goes 4, 2 and 156 is 78. Let's see, does 3 go into 78? Sure. 3 goes in there 26 times, which is nice because that's actually just going to be 2 out of 13. And then we can do the same sort of thing here. 2 goes into 156 78 times. 10 and 56 could be knocked down to 5. 28 and 78 are both even. So 14 over 39. So, fun with fractions. You can also just type it all into a calculator. It's also non-zero probability that I screwed up along there somewhere. So 2 over 39 plus 2 over 13 plus 14 over 39. And 2 over 13 is 6 out of 39. I just multiply by 3 to get a common denominator. So what does that make? 22. Come on, work with me. My pen just stopped working. That's fun. We're going to pause. All right. So there we go. So we got 22. 22 out of 39. And of course, my pen stopped working. Great. So 22 out of 39. Now, the other question that I'm going to try to answer, but when my pen's not working, it's going to be a little harder to write it out, is a conditional probability. So what's the probability that the marble came from jar A given that it was a yellow marble? Okay. And so what's tricky about this problem is you should be able to use Bayes' theorem for it. And I've had a hard time getting the formula actually to work out. Maybe somebody could help out with how to use the information to answer it. I've been able to get the answer using the tree diagram, but I haven't been able to get the answer using the Bayes' theorem idea, which is that this is the probability that it was from jar A and yellow. Sorry about my handwriting. I'm using the trackpad at this point. Divided by the probability that the marble was yellow. So really, the only piece of information I need is what is the probability that it's from jar A and yellow. So maybe I should be able to get that now that I'm thinking about it fresh. So let's see if we can get this here. We know the bottom probability is going to be 22 over 39 because we just figured that out. So we're going to throw that right here. Now, what I'm going to do is change change these 4 yellow, 3 yellow, 2 yellow to represent the probability that it's from A and it's yellow. So there's only 0 yellows that are from A in this situation. In each of these situations, we only have 1 yellow. And in this situation, we have 2 yellows. So we should be able to pretty much repeat the calculations that I wrote out here in this probability of yellow line and just replacing those values accordingly. So let's do that here. So we should be able to do 2 out of 10 times 20 over 150 plus 2 times 1 out of 10. And then down here we'd have 0 out of 10. So that would lead me to think, and you can correct me if I'm wrong here, because lots of chances to make mistakes in these sort of probability problems. That would lead me to think that the probability of A and yellow is, let's see, 2 over 10. So then that becomes, let's see, 4. So that's half as big right there. So instead of being 2 over 39, it's 1 over 39 for that first probability. And then here, this is 1/3 as big. So instead of being 4 over 26, which is 2 over 13, we're going to make it 2 over 39. All right. So anyway, you can add those up and then divide that by the probability of it being yellow and get a conditional probability for it being from A, given that it is a yellow. So please let me know if I made a mistake or if there is an easier way to indicate this, and we'll keep working on probability.